Let's check what is alternate segment theorem. We have a circle with center O and a chord AB. From point A, we are drawing a tangent AP. Now this angle which is there between the chord and the tangent, right, this angle alpha, this angle will be same as the angle subtended by the chord in the alternate segment. तो यहाँ पर इस part of circle में जहाँ पर भी आपका ये जो chord AB angle subtend करेगी, that angle will be alpha only. So here in this particular case, if I am taking this as beta, then alpha and beta will be equal. This is also called as tangent chord theorem. Let's check the proof of this theorem. So it's given to us that AB is a tangent chord and AP is a tangent. We have to prove that angle PAB, that is this particular angle, is equals to angle ACB, that these two angles are equal. Construction, as in most of the case, will join the center with the points on the circle. So we'll join OA and we'll join OB. Let's check the proof of it. We know that the tangent is perpendicular to the radius. So this angle is 90 degrees. Let's assume that this particular angle is x. So if this angle is x, then this remaining angle here, this will be 90 minus x. Right? So here we know that this OA and OB are the radius, so they are equal in length. So this particular triangle where OA and OB are equal is an isosceles triangle, and equal sides have equal angle opposite to them. So angle ABO, that will also be 90 minus x. और ये वाला angle, this angle we can find with the help of angle sum property of triangle. So solving it, will get this angle as 2x. Now we know the central angle theorem, that the angle subtended by chord at center is twice the angle at the alternate segment. So if this angle is 2x, then this particular angle will be x. And if these two angles are same x, then these angles are equal. That's angle PAB equals to angle ACB. And this is what we had to prove. I hope the proof is crystal clear to you. We'll see you in next video. Till then, tata, bye bye.